Good day, and thank you for joining Modena's Infrastructure webinar. My name is Salome Fourie, and I am part of the Modena Infrastructure Department. I am the Civil Infrastructure Accounts Manager. Presenting today will be Anu Himan. He has recently joined our Modena family and is part of our Infrastructure Applications Engineer. Please direct all your questions to the Q&A box. All the questions will be answered at the end of the presentation. This webinar will be recorded and be sent through to you. If you've missed out any of our previous webinars, you are welcome to visit our Modena YouTube channel. For any other queries, you are welcome to email or contact me. My details will be in the chat box. Andre, over to you.
Okay, guys, so we're going to be starting with what you will learn today with Infraworks. So firstly, how Infraworks fits into your design process. This means understanding what Infraworks is, how to create more compelling models, as well as some things you will need to be mindful of. Then we will be moving on to how you can build and refine your existing conditions, and we will be talking about how you can build your models and how to supplement your model with some externally defined data. Then we will move on to creating your design, like some things you will need to know before starting, and the difference between the different types of data which will be populating your models, like sketch features and data sources. Then we will move on to creating your design, like some things you will need to know before starting and the difference between, and finally, we will move on and be providing a quick demonstration. We will put together all the stuff we talked about that is in Infraworks itself. So before you start, Infraworks is a rapidly developing software where the user experience is continuously updated. And the most notable updates is with the 2020.1 release, where the interface has been updated to the dark blue and gray version, which aligns more with the other Autodesk software like Civil 3D. The main difference comes in when looking at the previous versions of Infraworks, that is 2014 release 4 up to 2020.0, where you can see the parts laid out there. And then also 2020.1 onwards, which, as you can see, has the dark blue and gray schema to look more like Civil 3D, for example. Then how Infraworks fits into your design process. So the three topics we will be going through is what is Infraworks, the typical workflow, and then the benefits and things to be mindful of. So what is Infraworks in 30 seconds? It's used to combine huge amounts of different data to create a real-world environment where you can plan, design, optimize, and share your ideas. It's 3D model federation on an image-draped topography, which is imported via Model Builder. It includes GIS tools like Autodesk Connector for ArcGIS. You can create visually compelling views and flyovers, similar to 3ds Max, but just a lot simpler. And you also have some engineering design capabilities like roads, bridges, tunnels, etc. Moving on to conceptual design. So what you can do in Infraworks is it allows you to create detailed conceptual site designs where the most common use is for road and highway design. This works especially well when trying to show the road and highway in relation to its surroundings. Then we move on to site design, where multiple data sources and features are used, like Revit models, aerial imagery, parcels, and coverage areas. These can be used in conjunction with each other to display, for example, a parking area for a casino or a hospital. You can also do railway designs, where the movement of trains can be emulated, and this is done using your component road modeling tools. Then we have drainage design, where you can do watershed analysis as well as culvert and road drainage design. You can additionally enter rainfall data to calculate what the impact of those drainage systems would be. Then finally, civil structure design. Think of bridges and tunnels, as well as the individual components like piers, abutments, and girders. All of these can be modeled within Infraworks. Then contextual design. So reality capture. We can take data from other programs to generate more accurate models. So if the underlying data like drone survey data is more accurate, then overlaying designs like roads and bridges will also be more accurate. We also have access to a tool called Desktop Connector for ArcGIS, which will streamline your model in terms of existing entities and drainage systems. That is, if you have access to this platform. We can also enhance our model by importing 3D objects from Revit, 3ds Max, and Civil 3D, which can be stylized within Infraworks to provide accurate visualization of this project area. Part of the 3D models is Revit model integration. The distinguishing factor when using this function is that a shared coordinate can be set up to geolocate your model within Infraworks. And then moving on to Civil 3D, you can import any corridors from Civil 3D, and if your coordinate systems are set up correctly, they will be accurately geolocated within your Infraworks models. So moving on to analysis and simulation. After moving through the stages of conceptual and contextual design, we can move on to analysis and simulation. I'll be quickly running through the different types of analysis available within Infraworks. Number one is line of sight analysis. This gives you color codes for site failure issues when looking at interchanges and intersections. You can do traffic simulations, which will give you an animation of the flow of traffic through your model, and you will be able to optimize your roads using that. We have mobility simulation, where you can animate the movement of people or cars within parkings. Then we have flood simulation. It is as you see there, but mostly used for coastal design projects. Then corridor and profile optimization. This analysis will be processed in the cloud with the input that you put in, and then it will provide feedback to your model, and you can then use this information to optimize your roadway. So visualization. This is where you can produce a storyboard animation, which utilizes a combination of camera movements and animations to create a video presentation of your project area. This animation can then be exported to video format and be shared to your project stakeholders and clients. We can also alter the feel of our model by incorporating atmospheric effects like the changing sun and sky conditions. And from there, your models can be exported to 3ds Max to incorporate new visuals or animations which are not available in Infraworks itself. Within Infraworks, you can also create high-resolution snapshots and create detailed zoom windows like shown here, and those can then be shared. We can also animate certain objects in Infraworks like the movement of a crane or an animal. And what you can do is take these objects to 3ds Max, animate the objects, and then export them as either a DAE or a collada file format, and then import them back into Infraworks, where from there the animations will continue running in the model until you tell them to stop. Then collaborating with others. We need to understand how we can share and collaborate with others on our models, locally and in the cloud. Firstly, we have local collaboration, where users can store their data on either their computer hard drive or a network drive. One thing to note is that a person can only access the model, only one person can access the model at any given time when using this method. Then you can use shared views even when you do not have access to BIM 360 or Infraworks itself. This means that the person that created the model can create a 3D snapshot of the model and share it with a collaborator. That person can then create markups which will be visible to the person working on the model as they are working on it. From there, we move on to our Autodesk Desktop Connector and BIM 360. This allows us to manage our data sources within Infraworks, and there's a small workflow shown over there. And finally, we have BIM 360 document management. Here you can create a BIM 360 project and store all your design documentation and models in a centralized cloud storage location. So the advantages of Infraworks. You can model real-world context almost instantly. It's used to aggregate huge amounts of data, like extremely long alignments or huge sites. You can combine disparate data types into one federated model. In other words, a multitude of data sources. It can be used for simple and effective visualizations. And you can also create multiple proposals from a master proposal to show different design options. You also have access to cloud-based utilities and analysis, as well as BIM 360 shared views and comments. So some things to be mindful of. One thing you should always look out for is the way in which your coordinate systems are set up. Make sure that the selected system corresponds with the coordinate system that you set up in your Civil 3D drawing for any given project. This ensures that the correct geolocation takes place when importing, for example, corridors from Civil 3D into Infraworks. Be aware that certain objects will have specific outputs or output formats after exporting, which will cause them to only work in the correct software. Always make sure that when working in a team, that everyone is always on the latest version of Infraworks, because models must be updated when loaded into a more current version of Infraworks, and they cannot be reverted back to the old versions. So it is not backwards compatible with older versions. When looking at data source quality, make sure that you know what grid your surface is surveyed on, and also what the date and available aerial imagery is currently on from Big Maps. Also try to understand the level of detail in your model, because the more information in your model, the bigger the file size is and the longer that it takes to process. So Infraworks is an ideal tool for preliminary and conceptual design. It has a strong partnership with AutoCAD Civil 3D, which can import the preliminary design to further design development. AutoCAD Map 3D is a GIS editing tool and connects to the same data sources as Infraworks. Changes made within the Map 3D environment can, if configured properly, go directly to the connected GIS data source. Infraworks is an excellent data aggregator, visual, and preliminary design tool. When editing data sources, Autodesk Connected for ArcGIS lets you import GIS data while working on design models if you have access to that platform. So then, moving on to building and refining your existing conditions, this will be split up into two sections, which is building your model and then supplementing your model builder data with external data. So first up, we will be looking at the new button. That is when creating a model. This is used to create a model from scratch, but the catch is that you must populate the model with your own data, such as topographic surface and aerial image. As you can see, you start on a blank slate. Then the model builder button. This is the most frequently used option, which is used to open a browser interface where you can either search a location or zoom in on the area of interest, and you can create a model up to 200 square kilometers. So when using Model Builder, you can use shape or project files to define the extents of your project area if you have that set up beforehand. Note that your polygons cannot be more than 1,000 vertices, and you have to avoid self-intersecting polygons, otherwise your model will be corrupted. You can do a model up to 200 square kilometers or a length of 200 kilometers lat long. In other words, 1 kilometer wide and 200 kilometers long. That is the limitations of this model builder software. As you can see there, there's the button highlighted where you can import a shapefile. So then creating a new model from scratch, you can define your extents from a file. This includes shapefiles, ASCII files, and geotiff files and more. So then, depending on which version of Infraworks you use, different methods of storing your models will be used. For 2019.0 and up to 2019.3, you will need a BIM 360 account to save your models, seeing as it would automatically be published to your BIM 360 account after completing its cloud rendering. For 2019.3 hotfix 1, which was released in March 2019, you can download your models locally and then later upload them onto Civil 3D using publishing tools. Then Infraworks 2020 and onwards. Once you create your model, if you are signed in with your BIM 360 account, and you receive your model back from cloud processing, it would give you the option to either store your model locally or in a BIM 360 project. You can do this. You can also save it locally and then publish it to BIM 360 later using the publishing tools. So your model builder data sources. These are just some of the sources from where your information will be aggregated. So roads and railways use OpenStreetMaps to extract their features and create those in the model. Buildings are also extracted from OpenStreetMaps dataset. Note that some areas will be less populated with buildings than others, depending on the amount of times or the amount of time spent in that area by OpenStreetMaps. Your aerial imagery is extracted from Microsoft Bing Maps, so your imagery is only as current as shown in Bing Maps. And your terrain. So the terrain is created on two different grids. You can get a 10-meter grid and a 30-meter grid. Currently in South Africa, we are working on a 30-meter grid, whereas in America, they have a survey grid for Infraworks on a 10-meter grid. So depending on where you are looking at in the world, your surfaces will be different accuracies. Your water bodies are also extracted from OpenStreetMap and then displayed within Infraworks. So when building your existing model, you can import different types of file formats. So firstly, you have your file-based imports, like, for example, a Revit model or a Civil 3D model. Then you have your database files, which is, for example, a Excel spreadsheet. And then you can use your Autodesk connector for ArcGIS if you have access to the platform. This will bring in existing pipe networks, etc., from ArcGIS itself. So when looking at importing file formats, you'll see the highlighted icons. The rectangle would mean that the file is processed locally on your machine before being imported into Infraworks. And when seeing a cloud, that means that it's using cloud processing before bringing it into your Infraworks models. You can use your application options to enable Navisworks-based local import. That is, if you have Navisworks installed on your computer, then most of those objects, as shown there, like AutoCAD DWG with 3D objects, your AutoCAD Revit, your DGN 3D models, IFC files, and SketchUp files will then be locally processed through Navisworks instead of being cloud processed. So when supplementing your model builder data, just hold on 1 second. When supplementing your model builder data, there are some examples. It creates coverages in Civil 3D and adds georeferencing to images using raster design. Here are some examples of objects that can be imported from other software into Civil 3D and the workflow that takes place between them. So with Civil 3D, you have surfaces, coverages, and tree points that you can bring into Infraworks. With Revit, you can bring in 3D architectural models. With Plant 3D, you can bring in full 3D plant models. Recap Pro, that can import point clouds and orthophotos, which are also georeferenced. With AutoCAD Map 3D, you can import GIS data. And with AutoCAD Raster Design, you can georeference images and then bring them into Infraworks and drape them over a surface. So point cloud data. We can go and fly a drone on site to take aerial images, submit that to Recap Photo, and then that point cloud can then be used to generate the terrain as well as an orthophoto to drape over that terrain model. Point clouds can also be used to extract vertical features or horizontal feature lines like curb lines and grade changes. These can then be taken back into Civil 3D where those entities can be utilized. When looking at Autodesk Connector for ArcGIS, you can supplement your model with information from Esri ArcGIS. You might need an account to import most information, although some of it may be publicly available. You can navigate to either the ribbon or data source manager to add GIS information into your model. And after modeling, you can publish this data back to either a FGDP which is a file geodatabase, or directly to ArcGIS. You could also save the edited content, save back the edited content depending on your level of permission on the Esri ArcGIS site. When looking at third-party providers, if you're struggling to find public GIS information, you can always go to your web browser and do some common searches to see what comes up. If the third-party GIS site does provide a download function, then you can download that data and import it into your model. Here are some examples of searches that you can do. For example, when looking at Australian or US GIS imports. We should have the same type of system for South Africa also set up. Then moving on to creating your design. So here's a step-by-step workflow. The workflow has been broken down into a simpler version. Existing context can be modeled by taking the model builder, adding features from other programs, and augmenting the data with information from other products. Then we can start developing our design by creating features like roads, buildings, and bridges. We can also add styles to manipulate what they look like, as well as reviewing the models with analytics and themes. Once we have developed the concept design, we can start sharing it with others, known as collaboration. This means asking for markups and feedback from colleagues or stakeholders, and they can then implement those changes. Keeping everyone up to date with the model via shared views or BIM 360. Once everything has been settled on the design, we can start with visualization. This means presenting the model using still shots and flyover animations. And then afterwards, the project can move on to detailed design through Civil 3D or other software. Then before you start, some important things to note. Is once you have created your model, there are just some things that you need to be aware of. One is the application options, which affect all models that you open in Infraworks. So not only the model that's currently open, but all models. That is used to update like the units, which will be governing all of your models, as well as your 3D graphics, the performance on which your machine runs, the way point clouds are generated, etc. The second is your model builder properties, which is specific to or your model properties, which is specific to the model which is currently open. This option contains settings such as your coordinate systems, your model extents, your model time, as well as your road design standards. Then proposals and bookmarks. These are other systems that are extremely important when using Infraworks. So proposals are used to organize your model into different design options, whereas bookmarks are your points of interest. When clicking on a bookmark, it will zoom you directly to a view that you have saved to enable easier movement through your model. Then the other systems, So proposals are used to explore different design alternatives. New proposals are always started from another proposal, where you have your master proposal as a base, which you cannot delete, or you can edit it, but you cannot delete it. Proposals can also be compared or merged to show difference between different designs. Your master proposal is your as-is state of your model, usually your existing conditions. When using Model Builder, you would leave your master proposal as is and create your other proposals from there. These proposals can also be compared to your new designs. As I said, you cannot delete or rename the master proposal. Then managing of surface layers. When we navigate to the surface layer manager, we can add different surface layers and also change the visibility by clicking on the globe. Remember to switch off your unnecessary layers, as they might impact the performance of your model. Too many layers means a slower model. And note that whenever importing a new surface, it will be brought in as uncategorized. To resolve this issue, you would have to drag it to the correct directory, for example, your terrain surfaces. From there, it will need to be configured to display in the correct coordinate system. That is very important. Then we will be moving on to our sketched features versus data source features. These are the main two features that you will be using within Infraworks. So the main difference is that sketched features are added manually. They have little gizmos that can be used to move them around. And this means that the contextual menu or the right-click menu can be used to edit the scales and the lengths. You can also rotate them from there. They have styles that are added manually and can be governed by the styles palette and also rule styles. In other words, you can open your style manager and drag and drop a style onto a sketched feature. Sketched features can also be copied. When looking at data source features, they have to be configured after added. That means that they have to work with the coordinate system of the model itself. Each source has a different configuration type. So there's a difference between configuring buildings and configuring imagery. So these styles of these data source features are usually governed by the original file from which they are imported. And as well, expressions and import scripts can give additional control if you have knowledge on that. So now we will be moving on to a show me how part of this presentation. We will be running through a quick demo of the software itself. So we're going to be running through the application settings, how to check your current version, and how to set up your speed versus quality settings. We will also be going through the model builder, using proposals, and supplementing your model builder data with imagery, buildings, and 3D models. We will also be looking at view settings. Let me quickly get open my Infraworks. Okay, awesome. Okay, so I have Infraworks open here now, and this is currently the latest version. How you can check your version is by going up here to the application options, gear icon, the general tab, and clicking about. Here you will be able to see the version on which you are currently. The application options are, as I explained, they govern the settings in all of the models that you open in Infraworks. Your navigation will be able to invert your inputs at model generation, which we usually do not touch. There are some more fine-tuned settings for your model creation. Your unit configuration, here you can set between metric and imperial, meters, decimeters, hectometers, whatever you want to use. At 3D graphics, this is very important. So you can either optimize for speed or quality. As you can see, speed switches off water reflections, realistic water, and your shadows. Also does not show back faces, etc. If you switch it to quality, it will update all of those. This is a lot more straining on your machine, so I would recommend that you work in optimize for speed. When looking at your data import, as I showed, you can use Navisworks if you have it on your machine to process your local imports instead of doing cloud importing. You have some extra settings here with your point clouds, for example, size and density of your points, as well as your user interface. You can quickly restore everything that you've changed. Okay, so over here, you can sign into your Autodesk account, and here you can sign into your BIM 360 account, as well as access your BIM 360. Here you have your shared views, your full screen settings, as well as your notifications. So when looking at the interface itself, the first thing that stands out is all of your models that you have opened. This is the recent tab, so it will show you all of the models that you have recently opened in descending order. You'll be able to see where your model is stored by either the little computer, which means local store. This is a sample model. If it is stored on BIM 360 or on a cloud server, you'll see a little cloud over there. If you have any models that show an exclamation mark in the top right corner in orange, that means that the model is outdated for the current schema. Once you open the model, it will update to the latest version. Here you can access your BIM 360 projects, which I currently do not have on my Infraworks. So when looking at your models, you can either open a new model, which has already been created. You can use the new button to create a model from scratch where you import all of your own information and objects like your survey, surface, and your aerial imagery. And then we have Model Builder, which is the most commonly used one. Let's just wait for it to open. Okay, so as you can see, you can move around with the left click of your mouse. You can zoom out, you can zoom in, and you can also set between a road view and an aerial view. The aerial view is a lot easier to navigate as you can actually see where you are going. Then we can search by location. Let's go, for example, Rustenburg in South Africa. So you can search, it will zoom you there, and you can just go to wherever. This is currently, I think, Glencore, the Glencore smelters in Rustenburg. And you can then see the size to which we are currently zoomed. So it's 13.43 square kilometers out of a maximum of 200 square kilometers. You can use your rectangle to select an area. It will show the size of the rectangle. You can draw a polygon if you need to show a more defined area next to a roadway or something like that, and then double click to finish. It will show you the size. And then you can also import a file, which I currently will not show, but you can import a shape file to determine the extents of your model. So then I'm going to go with the full screen. We can enter a model name and then add a description if you want to. Be sure to always allocate a coordinate system. If you're not sure what coordinate system to use LL84 as standard. I know we are currently within the LO27 WGS region, so I can select that. And then I can click create a model. For this purpose, for the sake of this webinar, I'm not going to create the model. I have it already created over here. And this is how you will receive your model. This is, as you can see, there's the entire Glencore site. It does bring in some buildings. It brings in almost all of your roads, intersections, etc. It brings in railways. But as you can see, not all buildings have been modeled in this area yet. There we have a township area, which has already been modeled. So now, looking at what we have here, we can quickly delete that proposal. Your model will be created with a master proposal. And as you can see, you cannot delete it, but you can edit it. What I would advise you do is, as soon as you've created your model, create a new proposal. We're going to call this new underscore buildings, seeing as you cannot have a space within the name. It automatically creates a copy of the entire model, and you can then move between these two. When looking at your views, you have two different views. You have your engineering view, which is optimized for performance. As you can see, it shows you the contours. It has a blacked out sky, and you have some anti-aliasing. Well, rather, your anti-aliasing is switched to 0. In other words, you've got jagged edges. When switching over to conceptual view, you can see that everything is smoothed out. We have a horizon, we have some sky conditions, and now this is where you can visualize the time of day. You can also edit these views for visualization, for interaction with objects, as well as editing or displaying your terrain contours. For the sake of this video, I'm going to be switching back to engineering view. So the application options govern all of your models. We've already went through that. And now we can look at our model properties, which is the second most important thing. So over here, you can see the name of your model, the coordinate system which you have selected. You can also define extents for when you export this model. You can add extra terrain styles. You can set a model time. That is when working conceptual view. And then you can look at your road design standards. So currently I have Ashtometric 2011 loaded, and I have it set to drive for us to drive on the left side of the road, seeing as we are in South Africa. We currently do not have any country kits for South Africa. So that is an unnecessary option. Then we will quickly be going through our difference between sketch features and data source features. First of all, I'm going to load a data source feature. I have my Navisworks based import switched on, so my Revit model will not be processing through the cloud, it will be processing on my machine itself. So if I want to import, I can select my architectural house model. See, Navisworks is working, it is connecting to online data or data sources. Okay, and as you can see, it does say it is configured, but that is because it was set up for another coordinate system. I know this model was set up for, I think, somewhere in America or Canada, so I can configure it. As you can see, the coordinate system for that was set up as the basic LL84, and it comes in on a different origin, as well as an elevation of 0, which is not correct. So for this, I'm going to be showcasing the interactive placing. If you have your shared coordinate point set up within your Revit model, it will come in wherever you have referenced it. I'm going to be using my interactive placing. And then you see, if I double click and say close and refresh, it will bring in your Infraworks model, your Revit model with full level of detail as designed within Revit. These models can also be moved around in different axes, as well as being brought up. So I'm just going to quickly bring it up so that that point ties in. There we go. It's in a little stilt over there. Okay, as you can see, with the data source feature, it brings it in with all of the styles already attached to the model. Then that is it for the data source features. You can also bring in ground imagery. I do not currently have any extra ground imagery for this area, but I will be showing what the surface layers manager does. Now looking at sketch features, if you go over to the Create tab, Structures drop down, you can say either building here or building over there. See, it also has a little shortcut. If I click on building, it brings up my style manager. I'm going to select that style and then draw in a feature or sketch a feature. See, it snaps to 90 degrees. Double click to enter. And then this is a sketch feature. As you can see, you can edit the roof height, for example, 30 meters. Just close my data sources. And you can also set rule styles and manual styles to this object. The main difference between these two is when it comes to styles. So I can bring up my style palette, go to facades, metal and glass, and then layer. And I can, for example, drag and drop the style onto the sketched feature, and it will automatically update. You can also set up a roof slope, drag the vertices out, add a vertex and drag that out, so you can completely modify the layout of your sketched features. Okay, so when looking at the surface layer manager, just bring it over here. Where are you? Okay, that opens there. Okay, for some odd reason, my style manager does not want to drag over. Just open my Infraworks again. Okay, looks like I'm not able to bring the style manager onto the screen. That is strange. Oh, there we go. So here it is. So as you can see, we have our roads. This is basically your layer manager as you would have in Civil 3D and AutoCAD. You have roads and railways. You have your water areas, which you can switch on and off. You have land use and your imagery. For example, if I want to switch my imagery off, I can say apply. And then you have a clean model. You can then come back to your data sources and you can add a raster image. And then when configuring, you can just select the coordinate system on which it should be. It would automatically pick up ground imagery, and you can select the coordinate system, have it match the coordinate system of the model itself, say close and refresh, and then drag the ground imagery from the uncategorized category up into your ground imagery, and then it would display. Unfortunately, I do not have a detailed aerial image that I can use as example for this. But that is basically it. That is how you can create and import and manage your Infraworks model. Okay. Now moving back to the presentation. Do we have any questions? Let's just go and check the chat. Okay, so currently we do not have any questions. Please feel free to ask anything, I will answer. When will we be able to see a model in Google Maps or Google Earth? Currently, the only way to see a 3D version of Google Earth would be to, how can I say, to set it to 3D view. Infraworks works in conjunction with Bing Maps. So it just imports from Bing Maps to Infraworks. So I honestly cannot answer when it is Google related. Any other questions? Can I import KML files from Google Earth into Infraworks? Yes, you should be able to. We'll just have to look into that workflow. You can import a KML file into Civil 3D and then export that as a shape file and then use that within Infraworks, as far as I know. What is the direct benefit of Infraworks in railway mapping when mapping for as-built? So currently you can draw railways and you can create bridges. So you can get quite a realistic view of your railway. The only thing I think currently is that the modeling is not as extensive as it is for component road design, but you should still be able to get a quite nice preliminary design, or at least a concept design for presentation purposes when using railways within Infraworks. For design purposes, I would still refer, or detailed design purposes, I would still refer back to other software. Any other questions? can you import AutoCAD 3D objects with transparency effect? You should be able to. Let me just quickly open my Infraworks. So you can import your AutoCAD 3D objects. And with that, if you have a transparency already set up within the 3D model, it should import as it is displayed within AutoCAD, within AutoCAD on your 3D object. I think I have not played around with this much, but I think you should also be able to set that property within the, let's look at this, base color, full style. Okay, so with Revit models, it does not look like you can do a transparency edit within Infraworks itself. I think it would have to be set up like that within your model that you import. Okay, guys. So I think that's about all we have time for today. This webinar will be uploaded onto our YouTube channel. There is the link. You can follow that back and check out some of our other webinars that we also have. We cover a lot of software, so check it out. Okay, guys, thanks for joining.